You flick the stove on without even looking. Blue flame, half a second, and you've already moved on, reaching for a pan, checking your phone, thinking about anything else. That flame is the most boring thing in your kitchen. It's also the oldest thing you own. Older than farming, older than writing, older than money, than cities, than every word in every language ever spoken. Older, maybe, than your species itself. The fire under your dinner tonight is the same fire that was burning before there were people to call it fire. And the story of how it got to your stove is far, far stranger than the one you were told in school. Because here's the thing you think you know. You think some clever caveman, somewhere, rubbed two sticks together, got a spark, and invented fire. One genius, one moment, one spark that separated us from the animals. That's not what happened. Not even close. The truth is that humans didn't invent fire. For an almost unimaginable stretch of time, they couldn't make it at all. They found it in lightning strikes, in wildfires, in smoldering grass. And then they did something far harder than inventing it. They refused to let it die. They carried it. They fed it. They stayed awake in shifts to guard it against the one thing that had always won before, the dark. So when did that actually start? When did the first human being look at fire not as a thing to run from, the way every other animal on Earth still does, but as a thing to keep? Hold that question, because we're going to climb backwards through time to find the answer. And every rung down the ladder, the date is going to get older and stranger and harder to believe. But before we climb, you need to feel exactly what fire was standing between our ancestors and, because if you don't feel the dark, none of the rest of this lands. In a South African cave called Swartkrans, there's a fossil, a skull cap. It belonged to a child, a young member of one of our ancient relatives, and it's roughly 1.5 million years old. Near the top of the skull are two small, neat, round holes. For years, people assumed another early human had done it. Murder, a weapon, the usual story we tell about ourselves. Then, in the 1970s, a paleontologist named C.K. Brain lined those two holes up against the lower jaw of a leopard found in the very same cave. They fit perfectly.
A leopard had killed that child, clamped its jaws around the little skull, and hauled the body up a tree or back to a den to eat it in peace. The punctures sit exactly where the cat's bottom canines sank in. And here's the part that should put ice in your stomach. A 2024 study argues that skull may not be some distant cousin at all, but our own genus, Homo. Meaning it wasn't the primitive branch getting eaten, it was us. And leopards were only one set of teeth in the dark. The very caves our ancestors wanted for shelter were wanted just as badly by cave hyenas and big cats. You weren't moving into an empty house. You were trying to evict the landlord. That is the world before fire. You are small. You are slow. You are soft. And when the sun goes down, you are on the menu. Now, with that in your head, let's find the oldest fire anyone has ever proven exists. Go to South Africa, to the edge of the Kalahari Desert, to a cave so big it swallows sound. It's called wonderwork. It means miracle in Afrikaans, and hold on to that word. In 2012, a team led by Francesco Berna of Boston University published something in the Proceedings of the National Academy of Sciences that stopped the field cold. Deep inside that cave, more than 30 yards from the entrance, far past the reach of any wildfire, any wind, any lightning, they found ash. Not just any ash. Microscopic traces of burned bone and burned plant matter, chemically fingerprinted, sitting exactly where they'd been left. In a layer dating back 1 million years. And they didn't just eyeball it. Berna used a technique that fires infrared light straight at the sediment to read the chemical signature of what had burned, and roughly how hot it got. The bone had been heated past the point any passing brush fire could explain.
Even the surrounding ironstone showed the specific fracturing you only get from repeated heat. This wasn't a hunch, it was forensic. Think about that for a second. Not 100,000, not 500,000. 1 million years ago, something was tending a fire in the dark heart of that cave. And it wasn't us.
Homo sapiens, you, me, everyone you've ever met, didn't exist yet. Wouldn't exist for another 700,000 years minimum. The creature crouched over that fire was Homo erectus, a different human species, shorter-lived, smaller-brained, staring into the same flame you'll stare into tonight while you wait for water to boil. Berna said that when the full picture came together, when he realized these beings had controlled fire, he got goosebumps. 1 million years is far enough away that it stops feeling like history and starts feeling like myth. But the ash is real. You can measure it. Now here's what makes that finding so important, and it's the part nobody tells you. They weren't making that fire. 1 million years ago, Homo erectus almost certainly could not strike a spark to save their lives. Literally, to save their lives. What they had was harder and, honestly, more human. They'd taken fire the world gave them by accident, dragged it deep into a cave, and kept it alive. That's not invention. That's devotion. That's a relationship with a living, hungry thing that would go out the instant you stopped feeding it. And keeping it was a craft all its own. A fire left alone dies by morning, so when a group moved, someone had to move the fire with them, cradling a smoldering coal or a lump of slow-burning tinder fungus that can hold heat for hours, shielding it from wind and rain like the most precious thing they owned. Which, in a very real sense, it was. Lose that ember on the trail, and you didn't just lose warmth. You lost cooking, safety, light, everything, until the sky happened to hand you another one, on its own schedule, not yours. Which cracks open a much bigger question, and this is the one this whole video is really about. If they could only keep fire 1 million years ago, who lit the first match? When does a creature stop babysitting borrowed flames and learn to make fire from nothing on command? Because that single leap is the real birth of everything you'd recognize as human power. If you're enjoying uncovering these forgotten truths, take 1 second and subscribe, because the next station on this ladder rewrites what the oldest fire even means, and I don't want you to miss where the number goes. Because here's the loose thread I have to pull before we go any further. That 1 million year date I just gave you, the one that stopped the whole field in 2012, it didn't hold. In June of 2026, as recently as it gets, a new study in the journal PLOS One, led by Maureen Montfort and her colleagues, went back into wonderwork. Same cave, deeper layers, and using a new method to detect burning inside fossilized bone, they found signs of fire not 1 million years old, but as far back as 1.79 million years. Let that sink in. The number changed while the field was still arguing about the last number. Nearly 1.8 million years of a creature carrying flame into the dark. That's not a date. That's a length of time your brain isn't built to feel. If you stacked up every human lifetime in that gap end to end, you'd run out of imagination long before you ran out of years. But a cave full of ash only tells you fire was there. It doesn't tell you what fire was for. For that, we have to climb up the ladder, forward in time, toward us, to a muddy lakeshore in the north of Israel, and to the moment fire stopped being a thing to survive and became a thing to live around.
The site is called Gesher Benot Yaakov. In 2004, Naama Goren-Inbar and her team published their findings in the journal Science, and the date they put on it was around 790,000 years ago. Now, the popular image of prehistoric fire is always the same. A random blaze, a lucky group huddling near whatever happened to be burning that night. But the ground at Gesher Benot Yaakov tells a completely different story. They found burned flint, thousands of tiny pieces. And here's the detail that changes everything. The burned pieces weren't scattered randomly across the site. They were clustered, concentrated in specific spots, the same spots, over and over, layer after layer. The team even mapped it in 3 dimensions, plotting every burned and unburned fragment. The burned ones piled up in tight little zones, while everything else spread out around them. You could see the fireplaces as plainly as chalk circles drawn on a floor. That's a hearth. Not a fireplace. A chosen spot, returned to again and again, deliberately, across generations. And around those hearths, they found what was being burned along with the wood. 6 different kinds of it, including plants that were good to eat. Olive, wild barley, wild grape. Food. Edible plants, near the flames, near the tools. Think about what that actually means. Someone stood at that spot 790,000 years ago and decided this is where the fire goes. And their children stood at the same spot and decided the same thing, and their children's children. The hearth, the single most ordinary object in your home, the stove you flicked on without looking, is nearly 800,000 years old. It is older than Homo sapiens. The home existed before the humans who'd eventually call it that. And that raises a question that sounds simple and absolutely is not. Why? Why go to all that trouble? Warmth, sure. Protection from the animals in the dark, obviously. But the deepest reason fire mattered isn't in the cave or on the lakeshore. It's in your own body. Here's where it gets extraordinary. Because to see the real payoff of fire, you don't dig in the ground. You look in the mirror. Compare Homo erectus, those firekeepers from Wonderwerk, to the ape-like ancestors that came before them. Something bizarre happens to the body. The teeth get smaller, the jaw gets weaker, the gut, the whole digestive system, shrinks. And at the exact same time, against every rule of biology, the brain balloons to nearly twice the size. That should be impossible. Brains are the single most expensive organ you own. Yours is about 2% of your body weight and burns around 20% of your energy, right now, doing nothing but reading this. You cannot grow a giant brain and shrink the gut that's supposed to pay for it. The math doesn't work, unless something else does the digesting for you. In 1995, 2 scientists, Leslie Aiello and Peter Wheeler, laid this out in a paper called the expensive tissue hypothesis. Their argument? You can only afford a bigger brain if you make a smaller gut, and you can only get away with a smaller gut if your food is already somehow easier to digest before it ever hits your stomach. And in 2009, the Harvard primatologist Richard Wrangham gave that idea a name and a mechanism in his book, Catching Fire. The mechanism was cooking. Heat breaks food down outside the body. It unravels proteins, bursts starches open, kills the things that would have made you sick, and hands your stomach a meal that's already half finished. Cooking is digestion you do in advance, with flame instead of gut. Want to feel how big a deal that is? A chimpanzee spends roughly 6 hours a day just chewing. 6 hours, nearly half its waking life, grinding raw food with its jaws. Cooking collapses that number. A cooked meal is soft, dense with usable calories, swallowed in minutes.
It handed our ancestors back hours of every single day, hours they could now spend doing literally anything other than turning leaves into paste. And if you think raw food is enough on its own, it isn't. Not for us. Not anymore. When Wrangham looked at modern people who eat strictly raw, unheated food, with every advantage of a supermarket and a blender, a striking share of the women stopped menstruating. Their bodies simply couldn't pull enough energy out of raw food to run a full human system. We are so committed to cooking that our biology now depends on it. We didn't just use fire. We outsourced part of our own digestion to it, permanently. There's even hard lab proof of the payoff. When the researcher Rachel Carmody fed animals the same food raw and then cooked, the ones eating it cooked pulled more usable energy out of every bite and put on more weight. Identical ingredients, more calories, purely because heat had already done part of the digesting. Cooking is about the closest thing evolution ever stumbled onto to free energy. So the smaller teeth make sense. The shrinking gut makes sense. The impossible brain makes sense. Fire paid the bill. Which flips this entire story on its head. You've been picturing our ancestors as the heroes who conquered fire, who reached out and tamed the wild flame. But look at the evidence and it runs the other way. Fire got into their food. Fire got into their bodies. Fire reshaped their skulls from the inside and switched on the brain that would, eventually, become the one you're using to doubt me right now. You didn't tame fire. Fire built the thing that thinks it did. And if fire could reach that deep into us, into our teeth, our guts, our skulls, then the next question is almost unavoidable. What did it do to the way we live together? Because a fire you gather around every single night isn't just cooking your food. It's doing something to the group. To see what fire does to a group of people, climb one more rung, forward again, to around 300,000 years ago, and step into another cave in Israel, this one called Qasem. What the researchers found here, in work led by Ruth Shahak-Gross and her colleagues, published around 2014, exact citation to verify, is deceptively simple. A single hearth, roughly in the center of the living space. And when they read the sediment layer by layer, they found it had been built, burned, and rebuilt in the same spot, over and over, across a huge span of time. Now, that might not sound like much, so let me tell you why it stops your breath. Up until now, on this ladder, fire has been a tool, a thing at the edge of the camp that keeps the cold and the predators out. But a fire that lives in the center of the space, tended for generations in one fixed place, isn't at the edge of anything. It's the middle. It's the point everything else is arranged around. That's not a tool anymore. That's a center of gravity. Picture it. The light only reaches so far. Past the ring of the firelight is the dark, and the dark is still full of teeth. So everyone comes in. Everyone sits inside the circle. And for the first time in the history of life on this planet, a group of individuals spends hours every single night in the same small pool of light, faces lit, hands busy, close enough to touch. You can't do much in the dark, but you can talk. You can share food. You can watch a child. You can pass on a story, a technique, a warning, a name. The anthropologists have a phrase for this, and it's a good one. Fire lengthened the day. Before fire, when the sun went down, life stopped. You found a hole, you hid. You prayed the night was over before something found you. Fire stole hours back from the dark. And what do you do with hours you didn't have before, packed shoulder to shoulder with your entire world? You become a society. The hearth didn't just cook the group's food. The hearth made the group. Sit that close, that often, for that long, and you get the whole apparatus of being human. Language sharpening, knowledge passing down, the raw social glue of people who face the dark together and decide to stay. Your family dinner table, your group chat, the instinct to gather around a screen at night in a lit room while it's black outside your window.
Every bit of it is the same animal, still circling the same fire 300,000 years later. Now, here's where I have to stop and be honest with you, because this is the moment the whole story almost falls apart. And if I skipped it, I'd be lying to you. Everything I've just walked you through has a clean, forward shape. Older and older fire, deeper and deeper into the human story. It feels like a straight line marching back through time. Real archaeology is never a straight line. So let me tell you about the most famous prehistoric fire in the world, the one that was in every textbook for most of the 20th century, and how it broke. Go to Zhoukoudian near Beijing, China. This is the home of Peking man, a Homo erectus population, and for decades it was taught as the crown jewel of early fire. The story went like this. Deep ash layers, meters thick, sitting inside the cave. Proof, undeniable proof, that these humans were burning fires here around 500,000 years ago. It was in the diagrams. It was the classic image. Generations of students learned it as settled fact. Then, in 1998, a team led by Steve Weiner published a re-examination in the journal Science. They went back to Zhoukoudian and did to those ash layers what Berna would later do at Wonderwerk. They looked at the actual chemistry, up close, at the microscopic level. And the ash wasn't ash. When they analyzed those thick, dark burn layers, they couldn't find the fine silica skeletons that plants leave behind when they truly burn. What they found instead looked, in large part, like washed-in sediment. Mud and organic muck carried into the cave by water, staining the layers dark. There were burned bones, yes, but no clear sign that fires had been built and burned in place, in hearths, the way there is at Gesher Benot Yaakov. The single most iconic fire in all of prehistory, the picture everyone had in their head, partly dissolved under a microscope. Let that land for a second, because it's the real point of this entire video. The story of fire is not a clean line of older and older campfires. It's a minefield. Ash washes in and looks like a hearth. A wildfire sweeps through a cave and looks like human control. For every site that holds up under the microscope, Wonderwerk, Gesher Benot Yaakov, Kesem, there's a Zhoukoudian, where the thing everyone was certain about turned out to be a trick of mud and time. The honest answer to when did humans master fire is that we are still arguing about it, still retesting the evidence, still watching famous dates collapse and new ones appear, like that 2026 study that just shoved Wonderwerk back nearly 800,000 years while we were talking. Which means the biggest question on this whole ladder is still wide open. Everything so far, Wonderwerk, the hearths, the shrinking gut, the growing brain, is about humans keeping fire, tending borrowed flame. But not one of these sites proves anyone could make it. So who did? When does a creature stop guarding fire it was handed by luck and learn to pull it out of cold stone whenever it wants, out of nothing at all? The answer isn't us, not first. It's the humans we've spent 100 years calling stupid. Say the word Neanderthal, and you already know the picture. Slouching, grunting, the dim-witted evolutionary dead end, the punchline, the thing we say when we want to call someone a brute. It's an insult with a species attached. Throw that picture away, because when it comes to fire, the Neanderthals weren't the students in this story. They were the chemists. Here's the leap we've been building toward this whole time, the one that separates keeping fire from making it. Across Europe, at Neanderthal sites, archaeologists keep finding a substance called birch tar. It's a dark, sticky pitch, and the Neanderthals used it as glue to fix stone points onto wooden shafts, to build a spear that wouldn't fall apart mid-hunt. Simple enough, until you ask the one question that matters. How do you make birch tar? You can't just find it. It doesn't drip off a tree. To get birch tar, you have to take birch bark and heat it, and not just toss it in a fire.
because too much oxygen and it burns to useless ash. You have to cook it in a low oxygen environment, held inside a specific temperature window for a sustained stretch of time. Too hot, you get nothing. Too cold, you get nothing. You are running a controlled chemical reaction using nothing but flame, bark, and an intuition for heat you can't even see. That's not a caveman warming his hands. That's a process, a recipe, repeatable industrial chemistry, tens of thousands of years before the word chemistry existed. The species we turned into a synonym for stupid was manufacturing a high-performance adhesive by precisely managing fire. When modern archaeologists sat down to reproduce it, they found there's a real knack to the thing. Get the heat or the air wrong at any step, and your yield drops to a useless smear. And it gets sharper. At a French site called Pec de Lazay, Neanderthals left behind hundreds of little blocks of a black mineral called manganese dioxide. For years, the assumption was obvious. It's black, so it must be body paint. But in 2016, a team led by Peter Hayes tested what that mineral actually does. Ground into powder and mixed with wood shavings, manganese dioxide drops the temperature at which the wood bursts into flame by around 100 degrees Celsius. There's a strong case they weren't collecting it to paint with. They were collecting it to light fires more easily. A firelighter cube dug out of the earth 100,000 years ago. And then there's the closest thing to a smoking gun. In 2018, researchers led by Andrew Sorensen put dozens of Neanderthal hand axes under a microscope and found a very particular wear pattern: scratches and polish running along the flat faces, exactly the marks you'd get from striking the stone against a lump of iron pyrite to throw a spark. Not carrying a coal from the last fire, not waiting for lightning, making it. Striking stone on mineral to pull fire out of nothing. The leap from keeper to maker, the single most important leap on this entire ladder, may belong, at least in part, to them, which forces the honest, uncomfortable truth back to the surface. That triumphant image you grew up with, one clever ancestor, two sticks, a spark, and suddenly humanity has fire. It is almost pure fiction. There was no eureka moment, no single genius. The ability to reliably make fire on command shows up shockingly late in the story. Hundreds of thousands, maybe more than 1 million years after our ancestors were already keeping it. And it shows up blurry, in pieces, across different human species, some of whom aren't even us. We didn't discover fire and ascend. We spent an ocean of time utterly dependent on a thing we could not create. And I want you to sit inside that dependence for a second, because we've climbed so far up the ladder of dates and sites and journal papers that it's easy to forget what this actually was. Strip away the science. Go back down into the dark with them. The fire is the only light in the world. Beyond it, nothing. Blackness, and the sounds in the blackness. Everything out there is faster than you, stronger than you, and sees better in the dark than you ever will. You have no claws worth the name, no fangs. You are, by every honest measure, prey. Remember that child's skull in Swartkrans, the 2 neat holes? And the single thin line between you and the thing that wants to do that to your own children is that flame. A flame you did not make, cannot remake if it dies, and do not fully understand. So you feed it. All night. Someone stays awake. Someone always stays awake. Because if it goes out, you don't just get cold. You go back to being food. That is the deal our ancestors lived under for more than 1 million years. Not man conquers fire. Man clings to fire, terrified in the dark, and refuses, night after night after night, for 50,000 generations to let it die. Every single one of your ancestors, without one exception, all the way back down that ladder, was a person who kept the fire alive long enough to have a child. If even one of them had failed, one cold night, one lapse, one flame gone dark, you would not exist. They didn't fail. Not once. Not in a million years. And that unbroken chain, every hand that ever fed a coal, every person who ever stayed awake to guard the light, leads to exactly one place. It runs, without a single missing link, straight out of that cave and straight to the flame you flicked on tonight without even looking. So let's go all the way back up the ladder now, to the present, to your kitchen, and finally answer the question we started with. When was fire discovered? The real answer is stranger than the myth, and it's about you. So, when did humans discover fire? After all of it. After Wunderwerk and its million years. After the number lurching back to nearly 1.8 million while we were still talking. After the 790,000-year-old hearths on the lakeshore, the shrinking gut, the impossible brain, the cave in the center of which a fire burned for 300,000 years. After Zhou Dian dissolved under a microscope, and the Neanderthal chemists cooked tar out of bark in the dark. After every rung on that ladder, here is the honest answer. There isn't one. There's no date, no name, no spark, no genius, no single clever ancestor, and 2 dry sticks. That story was always a comfort we told ourselves, because a species that likes to think it conquers things needs a moment of conquest to point to. But the evidence refuses to give us one. Fire wasn't discovered the way you discover a continent or a formula. It has no birthday. What the ground actually shows is not a discovery at all. It's a relay. Fire was found by accident, over and over, by creatures who weren't even us. Then it was kept. Then it was carried, hand to hand, coal to coal, night to night, across a span of time so vast it breaks the mind. A relay race with no starting gun and, so far, no finish line, where the only rule, the only thing every runner had to do, was refuse to let the flame go out before passing it on. And every runner did. That's the miracle hiding inside that Afrikaans word for the cave where the oldest fire sleeps. Wonderwork. Miracle. Not that someone invented fire, that nobody in over 1 million years ever let it die. And you're holding it now. Go back to your kitchen, that blue flame you flicked on without looking, the one you'd already forgotten by the time the pan was warm. Look at it again. It is not new. It is not yours. It is the same fire from the back of that cave, the same fire from the lakeshore, the same fire our whole strange family clung to in the dark, handed forward across 1 million years of trembling hands and sleepless nights, and set, at last, into a little metal ring in your wall. Every human who came before you was, in some quiet way, a fire keeper. It's the one job that never ended, the single thread that ran unbroken through every ancestor you will ever have. You do it now, too. You just do it so easily you never noticed it was the oldest thing you do. When you cook your food, you are running Wrangham's ancient bargain, feeding a brain too expensive to exist any other way. When you gather people into a warm, lit room while the night presses on the glass, you are sitting at Kesem's hearth, doing the exact thing that turned a scattering of animals into a society. You didn't inherit a gadget. You inherited the fire. And the strangest part, the part worth sitting with tonight, is this. For 1 million years, every keeper of the flame lived in terror of the moment it might go out, because none of them could make it come back. You are the first link in that entire chain who can. One flick, one spark, on demand, out of nothing, any time you want. The thing your ancestors stayed awake for 50,000 generations to protect, you can summon and dismiss with a fingertip and never once feel afraid. They would not believe what you can do. And you do it without looking. So the next time that flame catches under your dinner, give it the half-second it's owed. Because you are not using a stove. You are the current runner in the oldest relay on Earth, holding a light that has not gone out since before your species had a name for itself. You never discovered fire. You inherited it, still burning, from a million years of hands that refused to let it die. And every night you light the stove, you catch it again.